All right, so the focus of this lesson is our altitudes of triangles. Mathematically speaking, an altitude of a triangle is the perpendicular segment from the vertex to the opposite side, or to the line that contains the opposite side. So in this case, our altitude is here between P and R, but if we have an obtuse triangle, our altitude is actually outside of the triangle because it must form that right angle. Mathematically speaking, we get what's called an orthocenter if we look at all of the altitudes of a triangle. So if we draw the lines perpendicular from each vertex to the opposite side, all of those points meet at what is called the orthocenter. The location of the orthocenter depends on the type of triangle. If it's an acute triangle, the orthocenter is inside the triangle. If it is a right triangle, it is on the triangle, specifically at the right angle. If it's an obtuse triangle, the orthocenter is outside. Let's go ahead and take a look at our first example. Find the coordinates of the orthocenter of the triangle XYZ with vertices at -5, -1, -2, 4, and 3, -1. Let's start with point X at -5, -1. And then Y at -2, 4. And then Z at 3, -1. Our triangle looks approximately like this. Sorry, my sketch is off just a bit. Go. And we would like to draw our altitudes. So remember, the altitude goes perpendicular to the opposite side from the vertex. So there's 1. And then here's where we're going to have to be careful. That one's obvious because this is horizontal. The other ones, we're going to have to be a little more careful. So when we look here at this side XY right here, we're going to have to note its slope. And by finding its slope, we will allow ourselves to create this perpendicular. So our slope for XY is what? Well, it rises, if we look closely, it goes from -5 to -2. That's our run, and it rises, let's do rise first, from -1 to 4. So it rises 5, and it runs 3. Now, in order to do perpendicular, so the perpendicular slope, remember, is the opposite reciprocal. So our perpendicular slope will be reversed, 3/5, and instead of positive, it's going to be negative. Okay, so what we're going to do is from the Z is we are going to make sure that our slope is a -3/5. So we're going to reverse this. So let's go up 3 and left 5 from point Z. Our Z is at this point right here. We're going to go up 3, 1, 2, 3, left 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. And then we're going to attempt to draw that as straight as we can. And we see that is in fact our perpendicular. Now we're going to do something similar to find our perpendicular from X to XZ, or sorry, from X to YZ. So let's find our slope of YZ. And then here's Y and Z. So from Y to Z, our rise, remember, is our Y coordinates. We go from 4 to -1, so we went down 5. And our run, we go from -2 to 3. So our run is 5, so our slope is -1. So our perpendicular slope is, instead of 1/1, -1/1 is +1/1. So we are going to go from X, and then we are going to go up 1/1, up 1/1, up 1/1, up 1 over 1. So like that. And then if we look closely, remember all of these should intersect at a single point, and it does appear that they do right here, and that point is negative 2, 2. So our orthocenter is at negative 2, positive 2. All right, go ahead and give it a try. Plot the points, identify those altitudes, and find the point of concurrency, that orthocenter. Try it again. All right, now that you've tried a couple and seen an example, go ahead and give it some practice.